So in Montana and Idaho, we have what's called the Belt Formation. It fills up a huge hole in the flood, up to 20 kilometers deep, I might add, and it uplifted and buckled, and you can tell the depth from the beds are tilted like that, and you just measure the perpendicular 20 kilometers. Ooh, wow. Anyway, the quartzites outcrop mainly in western Montana and northern and central Idaho, right in this area, right in there. Anyway, the big picture on how they have formed during the flood is sheet flow would start out moving these quartzites as the Rocky Mountains were uplifting. All the rocks are being eroded, the softer rocks are being pulverized, but the resistant rocks were being tumbled and they become rounded. And they move further out from their source, from right in that area by sheet flow. Way out in here. I don't mean to imply that we just had these narrow areas. I need an artist to redo this and fill up the whole area. But as they further out they go, they become smaller and smaller. And we find them way out in here, which I'll get to. That's 800 miles from their source. But as the Rocky Mountains uplift, this is the northern Rockies, it splits the flow, and then the rocks get spread not only east, but start going west and round. And I've seen big, huge, thick layers of these 2,000 feet thick of just all quartzite rocks. And when they uplifted, the top gets eroded and big chunks get eroded and they're round down to boulders. And anyway, here's where I find them west of the Continental Divide. The green triangles are the locations. I've seen many of these areas. And the larger areas like this are larger areas of quartzites. And here's a larger area right in here. Now, some of these are on top of the Wallowa Mountains in northeast Oregon. At the very tops of the mountains you have these quartzites. These are, some of them are on top of the Blue Mountains. These are on top of the lava ridges around Yakima. 4,000 feet above the Columbia River right in here, you find these rounded quartzite rocks, indicating, since they're from the flood, that the Columbia River basalts were laid down during the flood. You find them through Hell's Canyon in here. I find them clear to the Pacific Ocean. The most interesting place I find them is in this area of Puget Sound right in here, mixed in with the glacial debris. The glacier went down clear to Olympia, Washington. I believe it surged down from here on water. And it picked up a lot of the rounded rocks that were deposited before the Ice Age. The Ice Age occurred after the flood, by the way, which I'll talk about this afternoon. And 6 locations I verified the rounded quartzite. Some of them still have the percussion marks on them that you find, which I didn't get into, but the percussion marks on these are semicircular cracks which indicate that they were deposited at high-speed flow. This is a location on the top of the Wallowa Mountains in northeast Oregon, 8,200 feet, and we found a patch of these rounded rocks. They're supposed to be 1 meter in diameter, which I couldn't find. It's probably underneath this snowdrift. But this is the largest one I find. Rounded and smooth by water. I was hoping to bring that home for my garden, but first of all, we couldn't get the horses up there. And secondly, I was told that they probably couldn't carry that because that boulder, we estimate, weighs 440 pounds. And by the way, there's even gold in these areas. There were active gold mines in this quartzite gravel at the top of the Wallowa Mountains until they made it a wilderness area. The gold was moved hundreds of miles with these quartzite boulders. That gives you some of the idea of the speeds of these things. And by the way, the fastest flash floods on Earth only go 20 or 25 miles an hour down a steep slope. But some of these velocities, and I've calculated some of them, are 2 to 3 times the velocity of flash floods. I think even over 100 miles an hour. Some of the places where we found them in east of the divide are right in here on top of the Cypress Hills, 75 feet average. Billions of these boulders out further, out in here, and on what's called the Flaxville Plateaus out in northeast Montana. We also find them out in here in Saskatchewan underneath the glacial debris. I mean, we're talking about 800 miles from their source. Across the Continental Divide is where they traveled. In southwest Montana, where I live right there, we find these huge areas of quartzites right in here. Northeast of Jackson, 11,000 feet thick over this area, going up to Yellowstone Lake in Yellowstone Park. Out in here, 15,000 feet thick, of rounded boulders piled one on top of another for 15,000 feet. And the top was eroded off, by the way. We also find them on the top of the Teton Mountains. This is a 3-day hike up there to find these on 2 erosion surfaces in the northern Tetons. Here they are, the rounded rocks. Some of them split open by frost action. Here's the largest one I found on top of the Teton Mountains. Rounded by water, 10,000 feet on the northern Teton Mountains. And here's a boulder. These are the percussion marks I tell you, very hard rocks, indicating tremendous pounding, exactly what we expect on the runoff of the floodwaters. So in summary, and this is a summary of 4 talks, 1 hour apiece. So you're just getting the highlights. Flood traditions point to a real event in human history. Sedimentary rocks, called strata in geological jargon, often are large scale and with little erosion between the layers. Just exactly what you expect in the deposition of the flood over large areas and with no erosion as one layer is piled one on top of the other. Fossils are often in huge graveyards, and mollusks are closed shells, all indicating rapid burial, unlike what you have today. Tremendous vertical uplift and sinking in the geomorphology summary. Continents are greatly eroded. The eroded sediments form the continental shelf and slope. Planation surfaces are formed, and they're common. Resistant rocks transported long distances. Conclusions. Mainstream geologists have great difficulty explaining all these features with their slow processes over millions of years model. All these features are worldwide, indicating a global event. Therefore, there is abundant evidence that Noah's flood really happened. And I want to leave you with this quote: "Your faith should not rest on the wisdom of men," which is what this evolutionary stuff, it really is. It's not data, it's not observations, it's their interpretations. Your faith should rest on the power of God. And if you want to know more about geomorphology, I only gave you a few things. There's a lot more in this book, Flood by Design. Thank you, and we're probably open for a few questions unless we're...
I'm having trouble understanding this rapid uplift of mountains and sinking of valleys during a flood. Why would that happen? How does it happen?
Why did it... All I did is we observed the effects. Like Lester King says, it's direct geological evidence that this has happened. We observed the effects. The why we don't know yet. There's a book called that was printed by 2 evolutionary geomorphologists in 2000 called On the Origin of Mountains, and they gave 21 hypotheses for it, of which they said we can't prove any of them. See, we have to have information down in the surface down there. What happened was a big heating event that caused the rocks to kind of expand, and then the mountain to go up? Could be. There's other possibilities. We really don't know. They suggested plate tectonics is one, but there's too many mountain ranges that are in the interior of plates, so that they rejected that explanation. Like the Transantarctic mountains are right in the middle of the Antarctic plate, for instance. So they don't know, we don't know. And I think the answer is going to be in geophysics. Seismology, I think, is a key area where we can see some properties of the rocks down below, and maybe we will learn heat flow and stuff. I think geophysics is the key to all this, but we're just getting into geophysics. We just barely scratched the surface. So, if you want to ask, come on up.
You want to take one more? Sure. One more.
There's 2 of them. How do I do this?
I don't know. Eeny, meeny, miny, moe.
Okay. Oh no, we'll be here for the next hour. As you know, John Baumgartner has a model of the moving continents. I've studied plate tectonics for 30 years, and I have trouble with accepting it as part of the flood to start with. And I say we need to do a lot more research to see if this really happened. There is evidence that it happened, but there's a lot of evidence that it didn't. So it's a mixed bag. So I, at this point, using meteorological jargons, give it a 20% chance of being correct. And that's all I'm going to say. I can say a lot more, but we're just getting into this flood modeling and flood geology, by the way. There's a lot more things to do.
Well, thank you, Mike. Let's hear it for Mike's presentation. Thank you so much.